Hi, very good afternoon to all of you. How is everyone? Are you fine at home? So basically, we have already finished our syllabus. So today, mainly, we will do our revision. Can you hear my voice clearly? Let me see who is already here. We have Boon Kyung, we have Chai Siu, we have Chi Ye, Chun Wei, Chong Yi, Han Xiang, Xin Shen, Jui Min, Ken Sing, Lok Jing, Mei Lin, Ernest, Tiong Le, Wei Hong, and Wen Yang. Basically, from now on, we're just doing some revision. So if you want to do your own revision, it's fine. But I will still give you some materials or some questions to practice if you want. But it's totally okay if you want to do your own revision by studying yourself. It's fine. By the way, I remember your coursework marks. I think you are also waiting for your coursework marks, right? Basically, roughly finish. Still have to double check. Finish your coursework. If I remember correctly, most of you get like 70 something. The highest marks is 80. 80. 70 something to 80. So this is the marks that you expect. I will, after I've checked, then I will post it to the Google Classroom. Then you double check with your midterm marks. Then you will know roughly how many marks you need to get in order for you to pass the subject. From what I can see is nobody need to do make group. So there is no make good test. So should be fine. So any question you want to ask me? Before we start our revision, anything you want to ask me? You can type at the chat box over here. Nobody need to do make good. I will post to the Google Classroom. Of course, I won't put your name there. There will be a table, just like normally, how normally it's done. So it's just a list with your numbers and also some simple marks there. So any question you have before we continue? So if no problem, then we can, I will start a Jamboard. Because today we only need to do one question. Most of the time, you can actually do your own revision. So I'll share the Jamboard to you. Then I'll paste the question there, over there. So let me copy. Today we just do this question. Because when I check all the papers over here, we have almost done everything already. Just maybe this question or maybe some questions which are not important. We try to do this question, practice it, and then the rest of the time you can do your own revision. If you have questions, you also can ask me. So these are what we will cover. Have you known your final exam dates? I believe you know, right? The final e-assessment date. So by next Monday latest, I will post your coursework mark. Then after that, you will have your final e-assessment. Then you'll finish my class already. So you can actually pass this computer architecture. I hope there is no one fail in my class. Because I don't want to I don't want to repeat. I don't want to repeat the class to you again. So please pass everyone. So this is the question that you need to do for today. If you have no other things to do, but in case you have any question, you can ask me using this time, because we will just do some revision. You can ask me anything you want to know. Meanwhile, I will let you do your own revision, and then I will go and find your e-assessment dates if I can find. So I hope you also have the dates already, right? But that is the tentative only. So any question you want to ask me? If not, then I will leave you to do your own work. So it's fine, totally fine. You want to do your own study, because I find the numbers is already dropping, but it's fine. It's a revision week. Thank you. The question you can post at the chat box. Class, just now I search from my record the tentative date for your computer architecture paper is actually 8th of May. Tentative 8th of May morning. Yeah, 8th of May. Please jot down this in your calendar. It's a tentative date. It's subject to change. It can subject to change. Yeah. So it's 8th of May morning. So because system is quite manual, so I have to search one by one. Yeah. So I've seen one of you have already done the question number first one, right? Yeah. So let me, yeah. This one is actually 8th of May, Saturday. It's a Saturday morning, 9 a.m. and 2.5 hours. Yeah. Computer architecture papers. So please prepare on that day. Happy is not a first paper. So you get to have some warming up period first before you have you can try my paper here. It's not very difficult. It's open book, open e-assessment. So you can refer to the lecture notes, but you're not allowed to search Google. Yeah. So that's all. Yeah. So by today is actually 16. So by 19, you should be able to receive your coursework mark. Yeah, I will post online. Then that's it. Then you can do your own revision. Yeah, today is quite quiet because I didn't receive any message from anyone. Can you hear my voice clearly? Let me see. Yan Cha, can you hear my voice clearly? Yeah, because I'm afraid I'm just talking to myself. Yeah, okay, thank you, Shinshan. Yeah, thank you. So let us discuss the answer that you have already given. Sorry, because just now I have to look at it manually to spend some time. So now let's go to the Jamboard. Where's my Jamboard? Okay. May I know who did this? Yeah, who have done this CPI? May I know who is the one have done this? Anyone? Who have done the question? Okay, never mind, but we discuss about the answer first. Let us suppose that you have running an important program on your computer, some name. So it's how many megahertz? 300 megahertz. Yeah, so 300 megahertz. So now you need to calculate the CPI and also the MIPS. How do you calculate the CPI? So your friend has already done this. Yeah. Okay. So the CPI is the clock cycle per instruction. So you need to find out the average clock cycle per instruction. So it's equivalent to, because your program usually we have this combination of the percentage of the instructions. So 40 plus 20 plus 10 plus 20 plus 10. Total up is 100. So you have to find the average clock cycles per instruction will be equals to 0.4 multiply 1 plus 0.2 multiply 1 plus 0.1 multiply 2 plus 0.2 multiply 3 and plus 0.1 multiply 5. Okay, so after done this, you can get your CPI. So very good to your friend who have done this. Sorry, I didn't see because I just searched for your timetable. For your information, for those who just come back, your tentative date for your computer architecture paper is on Saturday, May. Yeah, sorry, May 8th of May, morning paper. You have to come by 8:30. Yeah, so I will distribute a paper to you 8:30. Then you have 2.5 hours to answer it. Then at the end, you will be given half an hour to submit your papers as usual. Yeah, exactly the same. All the procedure is exactly the same. You need to turn on your video. You need to prepare a comfortable room for yourself, etc. So, okay, that's all. If got any changes, I will let you know. Yeah. So this is the tentative. Still have 1, 2, 3 weeks only, and not so far. But I think you have already done enough revision because you have done a lot of past paper. You just need to redo all the tutorials. If you don't have any parts of the tutorial, you can let me know. I will give you the answer as well. So now, what is the MIPS? MIPS is a million instruction per second. Million instruction per second. So how many clock cycles you have? So you have this much clock cycles. Yeah, 300 million clock cycles per second. So million instruction per second, so you divide by 1.9. Average is 1.9. So in average, you will get per second, you get 157 million per second. This is a very big, a lot of instructions count there. Okay, so we have 157.9. So at the end, you can put a MIPS there also, never mind, million instruction per second. Yeah. Okay, very good. Please give a big round of applause to your friend. We've done this correctly. Very good. So you can do now. Not yet. So please do this. Thank you. So let me explain a little bit since nobody has already started. Yeah, let's see. So suppose you turn on the optimizer. Yeah, at your compiler. Optimizer is usually something at your computer. And it eliminates 30% of the arithmetic logic instruction. For example, 12% of the total instruction, 30%. Okay, let me go and paste the table there also. Let me paste. Just without this table, very hard to calculate. We don't understand. Yeah, we put it here. So now, you eliminate, okay, eliminate 12% of the total instruction, mean 30% of the arithmetic logic instruction. 30% of the arithmetic logic instruction, meaning that here you eliminate 12 of the total instruction, 12%, so this remain is 28. But this percentage is changed already. So total is not that much. 28. Then 30% of load instruction. What's the meaning of 30%? This one is 14, right? If you take out 30%. Same with this. So, and then 20% of the floating point. Floating point is this one. If you take out 20%, you remain is 8, right? So in total, you have how much? Let me get a calculator. 28 plus 14 plus 10 plus 20 plus 8. So you get 80. Yeah, now you have already changed to 80. So when you divide, make sure it's divide to 80. All these cycles will remain the same. So now you calculate the speed up of this. So originally you have the 1.9, but now how much? See? How much? But how do you calculate speed up? Speed up of the optimized program. So reduce this. So you have to calculate the speed up. But 80% here, meaning that, yeah. So you still have to calculate. Yeah. None of other instructions are affected. That means you don't increase anything here, but you reduce this. So you have 0. You have only 80% of the instruction here. So let's calculate and give me the answer. Yeah, in 5 minutes. Can you try out? Anyone also can. Please try out and see whether you can understand the concept behind. Yeah, so Yan Chan said you can. Okay, thank you. So it's 28, 0.8. Anyone? Yeah, this is reduced already. Yeah, so sorry. So this one 1.9 lah. So when you reduce clock cycle per instruction, yeah, 1.9. So from here, because you also reduce the sorry, this one. So you just have to add up everything. CPI. CPI is what? But you only have 80% of the original instruction, you know. So CPI from here, yeah, you calculate first. Yeah. Then the speed up will be equals to 80% of this CPI. Yeah. That one divided by 80% of this CPI. Yes. So this is how it works. Of course, that one will be slower, right? So this CPI is 0.28 multiply 1 plus 0.14 plus 0.1 multiply 2, okay, plus 0.2 multiply 3 plus 0.8, 0.08 multiply 5. Let's calculate. Help me to calculate and give this, get this answer. Let's say 0.28 plus 0.14 plus 0.2 plus 0.6 plus 0.08 multiply 5. So in total, you get 1.62, right? 1.62. Yeah, and limits already. So from here, yeah, then only you compare with the 1.9. Okay, 1.9. So it's a clock cycle per instruction. But this one, you have to divide. You still have to divide by 0.8. It's quite troublesome. Divide by 0.8. Because this one will be 0.8 because only 80%. Yeah. So what you get? 1.62 divided by 0.8. Whoa, you get a 2 point something, right? 25. Yeah, clock cycle per instruction, but you only have 80% of the original instruction. So speed up equals to just now what you get. 1.9. 1.9 divided by 2.025 multiply 0.8. Yeah, what you get here? Yeah, let's give me the answer. Yeah, thank you. Yeah, please help me to calculate this one. Yeah, because I don't want to calculate until the end. Yeah, because this is a revision, so I hope everyone can involve and then we do together. Thank you. So thank you, Shinshan. Yeah, thank you. 1.1728. So very good. Let's see a big round of applause to Shinshan. Yeah. Now you know the secret behind. So this will be the answer. Yeah. This performance. So very good to Shinshan. Okay, let's see a big round of applause to Shinshan. Next, we will do the last one for today, which is the a little bit different a bit. Now, suppose that you turn the clock rate. Let me see how to do this. I also have to think because sometimes there's no formula. You have to think yourself. Now, suppose that the N3, this processor has been introduced with a faster clock rate. Originally, is 300 megahertz. Now 450 is a 50% increase. However, in order to make the clock rate faster, the AIM SCME engineers had to increase the CPI. Oh, you have a problem here. Increase CPI for arithmetic. Oh, now I go and get the table again. Without this table, I cannot do. Let me copy this table. Then I put it here. Now, I want to increase. You have to, the clock rate has been increased to 45 from 300 megahertz to 450 megahertz. However, because of this increment, so the CPI of for the arithmetic here, CPI, clock cycle per instruction, to 2. Arithmetic, logical, what's logical? Arithmetic, logical, and load. Logical and load. And load, 2, and load, arithmetic, logical, and load. Yeah, 2 cycles and floating points, instruction to 6. So this one becomes 6. Now calculate the speed up of SCME 3 over the SCME 2. Now the new processor, on the unoptimized program. Unoptimized. So now we're talking about the unoptimized one. So how do you calculate? So you calculate CPI. CPI equals to 0.4 multiply 2 plus 0.2 multiply 2 plus 0.1 multiply 2 plus 0.2 multiply 3 plus 0.1 multiply 6. Yeah, let's help me to calculate this. Can you help me to calculate this? Later we will calculate the speed up. Then after we have this, what we do? We calculate for one second. What is the rest of the clock rate? Clock rate you can 50% more so we see check off between them. Okay, thank you, Shinshan. So 2.6. Okay, very good. Thank you, Shinshan. So clock cycle per instruction is this one. So what is the speed up? Can you think about it? How to do the speed up? Maybe you think yourself. Then you also give me the answer. What is the speed up? Given 450 megahertz, clock rate is this. Clock rate is 450 million. How to calculate speed up? Clock cycle per instruction is 2.6. It's bigger. Just now we only had 1.9 here. So let's help me to calculate. Think about it, and then try to do. Thank you, Shishan. It's quite difficult to think about logic, right? but you know how to solve it, but to think about the formula. Because we have no formula for this. To think about it. Is it divided by the corporate? Divided. Is it 1.9 divided by 300 mega? Then divided by 2.6 divided 450 mega? Try to calculate and see whether the answer is can make sense. Speed up equals to time for the SCME2 divided by the time for execution time for the SCME3. So SCME2 is basically SCME2 one instruction 1.9 cycle. Yeah. So two of them also have the same instruction, right? So this one I divide by 300 mega. And then here you divide by 2.6 divided by 450. So it's a time for one instruction. Yeah, time for one instruction. Okay. Yeah, around there, the rate 300. Let's say time. Let's say if you have 1.9, yeah. So you divide and then you try to see what answer you will get. Yeah. Because this will be the time for one instruction. Of course, you can calculate for 1 million instruction. If you still cannot think of, you just assume that we have 2 giga instruction. Then it's easy for you to calculate. Now then you just assume that we only have one instruction. But this is just it's very abstract, right? Because you won't get one instruction. Let's help me to calculate what is the answer. Let's speed up for this. It's a big number, bigger number, right? Yeah, okay. 1.09. Okay, very good. Let's see a big round of applause to Shisha. Okay, very good. Yeah. At least we have done some revision today. We have cracked our head and then we try to solve the problem. Yeah. Okay, very good. Shisha. And any other question you want to ask me? By the way, anything you want to ask me about your final exam, your coursework or whatever? Yeah, final exam especially. Yeah. If no question, then you are allowed to leave. So thank you very much. Because, yeah. So, okay, Shipe asks, sir, total 4 questions in final, is it? Yes. Yeah, correct. You're right. Total 4 questions. Yeah, correct. You're right. Okay, thank you. So it's just like your previous e-assessment. Yeah, very standard one. Just everything is standard. 4 questions, 2.5 hours. Then you have extra half an hour. Usually extra half an hour at the back, but in front usually is about half an hour. Because you come by 8:30, then I will distribute the paper like 8:35 or 8:40. Slightly less than that because there are some trade-off there, right? Cover all chapters. Yeah, cover all chapters. Yeah, cover all chapters. Correct, you're right. Let me check. What is the chapters that we have? Cover all chapter. We have performance. Yeah, instruction set. We also need to know. Pipeline, yes. And then cache, RAM, virtual memory storage, I/O. All this may be about 50% of the portion of the question. The last one here also 50%, roughly like that. Yeah. 50% here and 50% storage system and IO. Yeah. Roughly, yeah, roughly only, yeah. Not exactly one. So any other question about your final exam? Thank you, Shipian. So any other question about your final exam? Yeah. So if no question, then happy revision. So and stay safe because currently the number of cases is rising a bit. So stay safe. Yeah. So all the best to you, and you may leave the class now. Thank you very much. Okay, bye. Thank you, Shinshan. Thank you, Maylin. Yeah, okay, bye.